Okay, so we have the linear programming model. Now we are going to implement it here. Okay, you kind of see how it's set up. So these are going to be our decision variables. And this time we have a whole table of decision variables, not just one row, but a whole table of decision variables. So this is kind of how it's going to be organized. Right, so Cleveland, so here, Cleveland to York, these are the origins. And Boston, Chicago, these the columns are the destinations. So you could see here, so these are the same thing we did before. 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, and so forth. So these are going to be our decision variables. And then here I'm going to have, for the row total, like this. If I add up all the numbers in the row, that must be less than or equal to the supply. So that's what this says. Like here, if I sum all the numbers, that should be less than or equal to the supply. And then column, and for each column, if I add up all the numbers in the column, that should be equal to the demand. And that's what it says here. If I add these up, here is the, I'm going to kind of use the sum, add up all these numbers, and that should be equal to the demand here. Okay, now I'm going to delete this and just redo it as a little practice, okay. Okay, so let's take a look. Here's our data, here's the data, and here, okay, this is also in practice. So this is going to be my objective function, the total cost. I want to get set up something like this. Okay, so I want to take the little unit shipping cost and multiply them by the corresponding variables and add them all up. And what formula, what function do we usually use to do something like this? Multiply and then add. What do I use? Right, sum product. So I could do the same thing. I use the sum product. Sum product of all these little numbers and all these variables. But how can I do it? Because I have tables here. I got table of the unit shipping cost, and I have table of the variables. Well, actually, you could do it. You could have not just 2 rows or 2 columns. I could also do 2 tables. I do the sum product with the 2 tables, or because I have 2 matrices. Okay. So, and then to make it more interesting, I'm gonna go kind of copy these numbers, 1,000, 4,000, and so forth, just to have something in here, just to make it interesting, but it's totally optional. Okay, so I put here. Okay, and let's see, and that's it. Okay. So on your computer, you could also kind of follow along and do what we're doing. So here are the kind of just to start something, and here I'm going to it tells you right here what to type. So you just type equals some product and then choose its 2 tables. And so I'm going to type sum product, okay, and I'm going to choose the entire table like this, and then comma, and then choose a second table like this. And it's going to do its thing. You multiply the corresponding pairs and then add them all together. So there it is, 42,000. So this is what we would expect, because this is the number we got from before. So you get 42,000 here. And then the row totals, as we saw before, we're going to sum. Now sum all the x variables in that row here. And then I'm going to say less than or equal to, and then supply. Instead of doing the work of typing the number myself, I'm going to just refer to the cell that has the number right here, so equal to F6. So usually it's better to do it this way instead of putting in the number yourself. That way, in the model, I want to kind of refer to the data section. So I want to have the model separate from the data. I mean, usually if you want to do it kind of systematically, and if you need to change the numbers, and then you're just going to make the changes here. And then if I'm just referring to numbers in the data, like here, then the numbers in my model will be changed automatically. And that's kind of more organized way of doing things. So I just refer to the cell instead of just typing in the number myself. And then also this way I could just now copy the entire thing down. So choose all 3 cells and then just copy it down, and that should give me the right numbers for the right hand side, right? And the correct sum formula like here. Okay, so that's the 3 constraints. Now I go over here. Now I want to say the sum of the numbers in the column must be equal to let's move this over. Okay, must be equal to the demand, which is over here. So it's equal to the cell that has the demand. And again, I could just copy the whole thing across to the last column. Okay, so there are our 7 constraints, 3 and 4 here. And what else? I think that's it for the, so we start up the Excel model that way, and we go to solver, and these are what we enter into our solver dialog box. Okay, so now let's go to solver, data, solver, and okay, I'm gonna do this over, so I'm gonna say reset. Okay, so the objective is over here, right? So click on that. Click on that cell that has 42,000. And do I want to minimize or maximize? I want to minimize, so let us check off min. And the variable cells are the whole table of the cells. So I choose all these, the whole table here for the variable cells. Then I add the constraints. Here I'm going to, here's one set of constraints. So I select these 3. Left hand side should be less than or equal to, and then the 3 right hand sides. Okay, and then say add, and I take care of the column constraints. So select all these 4 cells, and then choose equal to, and then the demand values over here. And say OK. Okay. And so this is what I entered. Yeah, so this is what I entered here. It's just in a different order, but it's the same thing. Okay, and then this part should be checked off, and this part should be simplex LP, and I just solve it. So click on solve, and it has found the solution. So here is our solution. Here is our solution. So is the total cost the same or different from before? Different, right? So it is different. Used to be 42,000, now it's 39,500. So it's a little bit less, right? So we're saving money. So by finding the best solution, we are saving money from 42,000 to 39,500. So would you ever expect this amount to be higher than what we found before? No, right? So this is supposed to be the best. So you'll always be, it could be equal, it could be equal or could be less, but it's never going to be more, never going to be higher, because this is supposed to be the minimum, total cost.